started, are we? We'll just wait for everyone to get seated.
So we just get the behind the wall.
All right, so we'll get started just in a minute. Got fancy cameras here. So can you guys hear us okay? Can you hear us okay? Yeah.
Yeah, all coming through fine.
Okay. We're gonna be a bit of a fun and games with the webcam, but the students are going to present 10 to 11 in here in the studio. They'll screen share, so you'll be able to see their presentation. Then we'll have a bit of a conversation on the webcam, this one, so you can pin that if you want to when we get there.
Right, so
yeah.
I think, just first of all, welcome everyone to the end of year jury. We've got a number of really exciting projects that we're gonna talk to. But I think we should start with introducing the jury panel. We are very pleased to have Professor Nat Chard, Professor of Experimental Architecture. It's fantastic. Thank you so much for joining us. And we have really the extended Hook Park and Design and Make family to talk through the project. So we have Martin Self, and we have the workshop team here. Jack Draper is joining us in a moment. We have Frederick's joining us, and then we also have online people that have taught you guys. So Zach's joining us, and then there Will Gowland and Jack Cardner, who's also been instrumental, is joining us online. So welcome everyone. So we have a really exciting day ahead, and we're going to start with the prototype house, Stud A. So if you guys are all ready, the floor is all yours. Thank you.
Thank you.
Cool. Hey everybody, thank you again for joining us. And we are Design Make Phase 2 students. I'm Weikun.
I'm Georgina.
I'm Sirisha.
And I'm Jacopo.
Yeah, we'd like to invite those of you joining us digitally to the place we have called home for the last year, the forest of Hook Park.
We'll be presenting yet another house of sorts that we built inside the campus.
We'll begin by giving you an overview to the project, explaining our brief for a house and the systems we constructed in response.
We'll then share a bit about the context for building houses that we've placed our project within, and of course, the forest.
We'll explain the major moments that influenced how these systems come to be, and then show just how we did it. Accompanied by some videos of our process, we like to use a presentation to immerse you in our year designing a house from the forest, in the forest.
We received our brief 1 year ago to design a house from timber that specifically considers the commercial market. The intent was not so much a one-off bespoke assembly, but a consideration of the production of houses at large, rooted in the energy production and as well as use, considering aspects of labor, economy, environment, and health. The name Stud A is a play on the systems we've developed, an A-frame and studs, but it's also a gesture to its future as a continual site of investigation, a temporary dwelling for the occasional short-term visitors, as well as a central campus shelter for daily studies. The study is a 1.5 house of sorts with a cozy bed nook to sleep one. Utilities are shared with the neighbors in South Lodge, and as such, Staying here is meant to be an experience that builds on community. We invite those spending time here to immerse themselves in the neighborhood of other student-made houses. We see the sharing of utilities as a catalyst for sharing and spending time together. The study is a house that synthesizes two unique systems that we each saw merit in their own right. The first, the core, is a mass timber assembly which provides a sheltered sleeping space in an A-frame and global structural stiffness. In balance with this is the Stud Plus, a light timber frame assembly that takes its explorations in the performance of the envelope. Early in the year, we developed a manifesto as a tool guide when designing systems, helping us to collaborate as a kind of reference to continually check our ideas with. We'll return to this list throughout the presentation and reflect on what we were able to achieve around it.
The first system we're introducing is the core. The system is a mass assembly system that consists of two parts, being the A-frame and the L corner wall. These two systems are placed in opposite ends of the structure, resisting it in shear load. The core walls are an assembly of round timber procured from the forest. The A-frame was built using a cedar stack put aside to be wood chip, and the L corner wall was built with Douglas fir. The first half of the core system, the A-frame, is a bed nook. Taking advantage that the timber is a good thermal insulator, we decided to have the bed nook in it. The space inside is small enough to be about the size of a single-person tent, allowing it to capture body heat, and the triangular structure also provides less surface area, resulting in less loss of heat. The L wall, the second half of the core system, provides the balance with the A-frame within the whole structure. Its major role is to enhance the shear load and also help carry the roof.
The Stud Plus is an additive take on its predecessor, the stud frame, also called light timber frame. It consists of two subsystems, one of framing and one of the envelope. Elements of the Stud Plus latch on the basic components of a more conventional stud frame. The 2x4s are notched, allowing a friction fit of a series of coppice struts used to frame and guide the bending of the coppice bolts. The load-bearing structure itself was admittedly not ambitious, cut, finished, and assembled in 2 days by 2 people. But in seeking to address a need for commercial housing, we found the system a compellingly efficient use of time and material, so long as we promise to respect the forest in our design. The coppice is connected to the studs, avoiding the use of any metal joinery to increase the potential reuse value of each stud after the life of the building is complete. We used beech dowels combined with scalloping for the struts and lashing to fix the poles to the coppice struts. We decided that the most effective way to clad the irregular geometry given by the use of coppice would have been a textile membrane. To increase the insulation value of the wall, a carpet underlay is sewn to the canvas following a mode similar to that of a yurt. Resolving the detailing of edges proved to be one of the most challenging aspects of the design of the Stud Plus envelope. Through the use of toggles and details borrowed from sailmaking, we resolved the seams with a rigid structure. To facilitate the shedding of water, a drip edge was achieved by sewing a flap halfway through the curvature of the wall.
The cabin is an emergent system in which the whole is greater than the sum of its parts. Though these two systems originated through separate beginnings, we quickly discovered that in conjunction, they solved many of each other's problems. The core provides a stable microclimate through scarcely processed roundwood, but using this assembly for the entire envelope would be an excessive use of timber and its performance. The Stud Plus deploys a more conservative amount of timber, but lacks an envelope, an opportunity for dynamic exchanges and adaptability. The stud alone, however, lacks a self-sufficient structural performance, but rather than relying on energy-intensive sheet goods, as is usual practice, the racking of this system is solved by the stiffness of the core. In combination, these two systems help each other to perform at their best. So we've prepared this video to kind of put you into our house. We need a YouTube link. Yes, there we go.
If it jumps, the link's in the chat. If it jumps on your end, virtual people.
In designing a home that would be applicable to the commercial market, we situated our brief in the current state of building and environment. The construction industry is responsible for nearly half of global carbon emissions, and half of that is just from heating buildings. While we have a great need to provide homes, we recognize the impacts that this has in contributing to waste and in importation of timber, where our ecosystems seem to bear the greatest burden of commercial supply chains. We sought to not just design a house from the forest, but with the forest, considering how our systems might generate reciprocally beneficial relationships to the future of productive landscapes.
Our initial design research at the beginning of this journey tried to survey the different timber construction systems through a series of 4 case studies. The research encompassed a broad timescale, going from the Neolithic to some of the most recent developments. 4 categories emerged from the vast set of buildings we considered, each defined by a central structural approach. We extracted one takeaway from each of these 4 cases. The indigenous longhouse from the tribes of the Amazon basin showed us a way in which you can build using a variety of species and interacting more fully with the forest. The heavy frame, the barn, proved a different way to use joinery without metal fixings. The radical simplicity of the light frame proved the power of an open-ended and flexible system, and the mass timber showed us the true insulative potential of wood. The initial research phase allowed us to complete a map of a broader network of systems inside which a building exists. We tried to determine the flow of energy, both in terms of matter, carbon, and heat, that flow through the production of a timber house, trying to find which part could offer us the best opportunities to intervene.
Now I will introduce our forest. This is Hope Park, a forest of 17 species, which were planted into compartment in 1950. In 2020, a compartment of spruce was clear-felled to produce a surplus of sawn timber beams. As a warm-up project to our program, we stacked these beams in a self-seasoning shelter. This practice of clear felling is a common monocrop plantations, the kinds of forestry management most often used for timber production. However, we recognize that these constructed landscapes privilege the profile of the forest, and by doing that, these forests suffer from a lack in biodiversity and resilience. We helped our forest trees to copy hazel, willow, and alder in its 10 years of growth. It informed many of our material prototypes, as well as our understanding of forest management. Coppice is a form of woodland management that takes advantage of most broadleaf's ability to re-sprout when cut. It makes up the understory of irregular forestry management. Otherwise known as continuous cover forestry, we see this form of management as a complex, resilient, and biodiverse practice. And so in our building, we use this as a driver of materials.
Using forest products as our material palette, we aim to produce prototypes using minimal application of energy. We took measurements depending on their insulative properties, environmental performance, structural performance, and finally reconsidering them as a forest product. We experimented with neglected forest products, coppice and cedar bark, which are abundant in Hook Park. Seeing as coppice was has a low economic value, we considered how to use it in mass as an insulative assembly. The bark being so light yet fibrous, and looking at its history of use by the indigenous people of the Northwest, we considered it as a cladding material. We produced mass and light assemblies majorly using coppice of various diameters. The mass assembly required excessive processing, while the light assemblies experimented with the flexibility of coppice. Using the prototypes we wanted to continue exploring, we built an A-frame structure consisting of 3 different panels, each of 3 different properties. Having learned our research and hands-on investigation, we returned to our manifesto to begin designing potential systems.
At this point, we'd like to take you through the origins and key moments in the development of our systems. First, why we built a stud frame in Hook Park. The light timber frame was first used in the early 19th century in what's called the balloon frame, and it hasn't changed much since. It's an open source assembly logic, and it's easy to follow, kind to low-skilled self-builders and easily modified with just a few power tools and a pair of hands. It's an incredibly efficient use of timber, needing only 15 trees for a single house, whereas a CLT house of the same size would require 3 times as much. Efficient as it is, the production of the 2x4 in respective houses has given way to economies of scale, implicating our most intimate spaces in mass commodity production. Having lived in a stud frame suburbia all my life, I found it troubling that architectural education and the discipline at large are typically dismissive of the light timber frame. Familiar, elusive, and ominous, this case study helped to unravel the pervasive black box light timber frame industry which proliferates the residential landscape. But perhaps the most alarming commodification in the system is that of the forest, where monoculture plantations are routinely cleared, with the only consideration being financial yield of its woody stuff called timber. In this way, the 2x4 becomes only a product at the end of a long supply chain, its origins from the potentially exuberant forest it grew from completely abstracted. Testing the system against our manifesto, it was not only an abstraction in how we build houses from forests, but also the lived experience in a house from a forest. Virtually no timber is exposed here, and flat textured sheet goods conceal its innards of still air insulation. This points to what Kielmo refers to as an epistemological error by thoughtlessly deploying insulation as isolation, as though it were ever possible to truly isolate a building envelope from its dynamic environment.
The approach to stud plus is twofold. The first, to make a stud that has more depth to it, metaphorically and literally. The other is to eliminate the need for plywood, exposing and celebrating the moments of the forest within this building. We aim to hijack the strength of the system and at the same time free it from its constraints. True to the plus in its name, the development of the system was additive. We'll share with you some of these key moments that led to the emergence of what we built, both in terms of failures and promises. The first prototype was a crude assembly of green willow bent onto an L-shaped 2x4. The most interesting thing here would have to be the strawberry hue that the willow turned when debarked, for a reason we never confirmed. The diameter of the willow was, however, too thick, bending the stud beyond structural use. The next iteration deployed 2 smaller hazel poles, which were much more pliable. We established components, strut and joists as members that would capture the hazel. We tested these panels as portal frames to find out if a brace could offer any racking resistance, but things were still pretty wobbly. With these panels built, we were able to span a membrane across and understand how the tolerance of the coppice would perform, which was fairly promising. Seeing a number of ways forward in the system, we looked to well-known housing types to imagine how this system could be applied. Having assembled panels at this stage, we consider how a manufacturer would play into the supply chain to be both efficient but also rooted in the forest. We proposed a logic for a local supply chain that would more directly connect the builders with the forester and eventual occupants. Seeing as commercial markets fluctuate, we wanted to design for a system that would be less focused on mass production and think about times of lower demand. We developed a more carefully crafted version of the stud plus using half-sawn and thin round studs. The prototypes were promising, but would have required greater section to have structural use. This would have meant cutting down more trees and would still have a less efficient yield than the energy required to harvest one large tree. We decided to keep 2x4 studs, but employ a greater use of coppice where possible. We replaced the top joist with coppice horizontals in between the stud so as to catch the ends of the belly pole. We replaced the sawn struts with scalloped and doweled coppice struts, which would carry the rail. This allowed the belly pole to be bent green within a panel, taking advantage of its springiness to hold it in place. This move had eliminated all the hardware from earlier versions, which drastically reduced its embodied energy. Thinking about the energy performance of the systems once built, we speculated that this rotund exterior could be used like a greenhouse, maximizing solar heat gain as the sun's angle of incidence would always hit perpendicular to the surface. A venting system was proposed at the top of the interior surface to manage the heat that would enter depending on climate needs. We produced 2 single bay prototypes backed with tongue and groove boards to test our heat gain hypothesis. One with natural cotton membrane, the other with a spare plastic membrane from TESS. The prototypes got hot all right, but only to the point of overheating when the weather was too warm to want any additional gain. For the most part, heat gain was negligible, with overcast day and was even cooler than the environment on one cold, wet night.
We looked to Tia's cook and neighbor in the forest's backyard yurt as an inspiration. We analyzed this system as a promising reference for cool weather membranes, a wax cotton exterior, and a felt lining on the inside. Simple details like a drip edge, Velcro seams, and a rope that acts like a belt to tighten the whole membrane were noted in the redevelopment. But Tia shared that the difficulty of a yurt was that it didn't offer good ventilation. This prompted a pursuit of an envelope in layers, which could adapt to its environment, further celebrating the energetic and experiential exchanges. Around this time, we began to synthesize the benefits that the Stud Plus and Core could provide each other. This was a major moment in resolving the whole design and allowed the Stud Plus to remain unclad, drastically reducing timber requirements for boarding and exposing the structure itself. We came to a design for the membrane called the Undressing Facade, using 2 pulleys to lift one of the panels up and reveal the structure below. While this mechanism offered more than sufficient ventilation to the structure on hot and stuffy days, the undressing would also allow users to fully transform their space from one of private shelter to a public venue or deck when they wanted. In this way, the building listens to the user's needs and at the same time requires very little energy to adjust changing climactic needs. One challenge in the system was designing all the seams and joints to serve their purpose at the lowest means possible. It seemed like there was 100 different ways to do one detail with the fabric, and so we decided to reach out to the Boat Building Academy in Lyme Regis for a sailmaking course. For 3 days, we all worked together to test different cladding options on a scale model and one-to-one prototype. Special thanks to Mark, our tutor, for the many useful tips. This course was really helpful in that it allowed all of us to rapidly prototype on the same thing at once, a nice change from working on our own focuses throughout the year. We learned the basics of sewing and how to scribe onto structures and decided on a sustainable source for canvas. By the end, we developed a taxonomy of necessary accessories consisting of rope, webbing, grommets, and Velcro. A close template was derived from our 3D model to account for the curvatures with additional tailoring done on the structure. And the production of the membrane itself was relatively straightforward and completed in just over a week with support to feed the bulky material through. But not all of the Stud Plus was, however, plus. Some of it was just stud. And so to clad that area, we returned to the early prototypes of bark ply to provide shingles for cladding. This is done by gluing 2 cuts of bark on their inner surface and compressing them together with a hydraulic press. At this point, the development of the Stud Plus has blended into its construction phase. Over the year, we worked as a group to split our efforts amongst these systems, And so adjacent to this development was that of the core.
As mentioned in our brief, we will build a temporary building. There's no heating and power system. We want to use mass timber to create a stable environment, but blindly using CLT will require lots of forest resource. So we were trying to find some other assembly to do it. CLT always requires lots of sawn timber. In order to save the forest, we are trying to use copsing wood to make a panel, could have a similar performance with CLT. Because the wood have randomly shaped and it's quite hard to process. Even we made lots of jigs to help us, but it's still gonna take lots of time to make it. I made over 600 wood bricks with hazel, and each of them needs 5 steps. And also because the processing are complex, it's hard to make everything accuracy enough for the final assembling. So we don't think it's a good way to do it. After that, we changed our mind to use less material to create a limited space in the building. If the space volume is small enough, it still could save lots of material. There is a saying in China, 好钢用在刀刃上. It seems good materials. It means good materials going to the right place. For all of the activities might happen in our building, sleeping must be the most in need of the stable environment. After that, we decided to use high density material to create a small bedroom. And for the rest activities, we could use light framing, which the material is not that intense in there. Then we all went to the woodland cabin, which is also has no heating system. We made a curtain tent and slept in there. Actually, our body would heat the tent quite fast, and also it make a big difference from the outside. We also recorded the temperature changing on the surfaces. This diagram is showing that the surface temperature rests up 2 to 3 degrees after I stay in there for 3 minutes. As for the material choosing, we also not use general CLT to build the core. Instead, the CLT panel will waste a lot of material. Using round wood could more friendly for the forest. And also, we almost could manufacturing everything, only use hand tools, except a timber miser wood, we do have one. In addition to creating a warm bedroom, we wanted the solid wall could make the whole structure more stiff. The A-frame structure we built before showing us is quite stable, and also the spacing there made us exciting. Initially, we wanted to extend both sides of the A-frame wall and curve it to carry most of sharing force from the stud walls and the roof. Then it will transport it directly to the foundation and make the whole structure stable. In order to use round wood to build a curved wall, we designed a T-joint. These flat surfaces fit with each other, and also the shoulder could carry most of sharing force. But then we found the same problem as when we're making the copsing bricks. It's very hard to make a jig strong enough to hold these heavy logs without shaking, because we cannot make the teeth joint that accuracy, so it will never fit together perfectly.
From our prototypes, we decided against the curve within the A-frame and instead introduced the L corner log to the far opposite end of the structure. These two assemblies worked really well with each other, strongly supporting the entire structure in shear. This design also allowed us to eliminate the use of 60 logs, and which a previous design required. Instead, we used 38 logs. Although 38 logs sounds reasonable in comparison to 60, it still required us to fell a minimum of 15 trees, which broke ours and Chris's heart. But conveniently, we found a large stack of cedar ready to turn to wood chip. We acquired all the timber from for the A-frame from this stack, but they weren't long enough for the corner wall that needed to support the higher end of the roof. So instead, we harvested 3 Douglas fir trees, acquiring 9 logs. Because the cedar logs were left outside to dry for a long period of time, their outermost layer was rotten, requiring us to remove about a centimeter layer deep. But because we were using timber in the round, it was structurally stable. The logs that went into the core were of 3 different types. There's the type 1, where the entire log only has parallel faces on either ends, being the extended inclined wall and the L corner wall. Type 2, the log within the A-frame with the dovetail cut, and type 3 that connects to the dovetail cut. While type 1 and 2 only took 3 days to produce, the dovetail logs alone took about 3 full weeks. The production of the dovetail logs started from the sawmill and were later worked on manually. Most of the tools used in the production of the logs, others than the miser, were a skill saw, handsaw, the widest chisels, and a mallet. The grooves within the logs required the use of a router. We also used a crosshair laser to achieve accurate cuts. Although working with round timber was quite complicated, especially with the quantity that we required, the flats made by the miser were a convenient datum for all our measurements. The tongues were only placed within the logs that were exposed to the exterior atmosphere, sealing any gaps that could form over time. The interior A-frame wall didn't require any, which allowed the bed Nook to be able to breathe through into the common space of the cabin. The tongue and the grooves also helped majorly in positioning the log during construction. The flooring within the A-frame was made with sawn spruce, while the bed frame was built with coppice, trying to eliminate any excessive use of sawn timber wherever possible. An insulative curtain was added to the A-frame such that the space inside could be sealed while sleeping, allowing the A-frame to capture body heat. Next, we will be showing a video on the construction of the cabin.
Let us know.
Reflecting on the project, we are both surprised and pleased by the building which emerged, a process which we could not have appreciated from the start.
The forest is expressed in this house as a great range. Every texture tells a different story about the tree's life and the processes chosen for its best use.
While learning so much about the ways of architecture could pattern with the forest, we also acknowledged that timber isn't always the best material for certain jobs.
It was an exciting challenge to build in such a visible site within Hook Park's campus. We considered the relationships to both the public interface as well as the less public residential area, hoping to create a space which could give back to both. Since its construction, we've each enjoyed spending time in here. It's cozy enough to settle down in with a book, but also engaging enough to incite new interactions. But we couldn't have completed this project without all the help we received from our staff, our phase ones, visiting schools, and especially that of our technical coordinator, Edward, and our research fellow, Jack, who stayed on to help us. We returned one last time to our manifesto as a final reference to check our ideas. We don't think we've quite achieved each item, but as a prototype of systems, we've learned a great deal from their building and how they could be improved. So that concludes our presentation, and we thank you for listening.
Thank you.
Thank you.
Thank you.
Can you guys hear us online? Yeah, okay. I think we'll open it up to questions from the room here, conversations, but also online. If you want to say something, just raise your hand and I'll try and make sure I see you if you're raising your hand. Okay.
I think maybe first of all, thank you so much for a wonderful presentation. And although you guys talk a lot about low embodied energy, it's been really amazing to see how much energy all of you have kind of put in these last 4 months. It's been super intense, so well done. I thought it was really important to start off the conversation like that. So, so yeah, by all means, let's all join in.
Can I ask what are your backgrounds before you? Did you all study architecture before?
Yeah, I think we all have.
These are largely sort of technical ambitions. Are there other sort of conceptual or cultural ambitions for the project that you want to discuss?
Yeah, I mean, I think cultural would be kind of rooting its relationship to the landscape and what it means to build with that landscape. And so I think that there is architectural value in that, but we did approach it, I think, rather pragmatically, just recognizing with our brief, this was for commercial housing, and so we wanted to kind of get in that mindset. But yeah, I think that there's a lot of things which emerged along the way that was very much our architect minds.
Such as?
Well, like perhaps we didn't have to make the membrane open. We could have had windows open and gotten ventilation, but there was architectural quality in that, and finishing of the roundwood, the use of that and the variety of textures it offered.
And what you built quite different from this model here. What stage was this, and what made it change?
Actually, the biggest change is the core part, as you say, the roundwood part. And like the final building, we got a diagonal roof.
is because all of the roundwood we use is from a firewood stack, and which is limited in 2.5 meters. So we're trying to use this kinds of lower value material. So we just like made that kinds of like different. And also like actually we because we cannot use the robot cell, we cannot make the whole like the structure got curved. So that's why we just change that into a regular A-frame, like as a like 2-flat wall.
So that was a practical thing, was it? You couldn't use the robot, or the robot was out of use or something?
Yeah, and also it's considering about the material, because it's just cost too much like logs, like 60 something. It's like all of us just think it's a big suffer for the forest. So we just kind of rethinking about the whole structure. How can we reduce the material using the house?
Yeah, but in terms of character, for instance, I mean, I maybe ask Martin about the sort of structural implications, but certainly in the spatial character of it, when you start to get these sort of hyperbolic curves, where I think each of the planes in this one has either a top or a bottom that's straight, and then an angle in the other chord, if you like, at the other end of it, and this makes these sort of hyperbolas that are these sort of strange shapes that we find in things like Richard Serra's torqued ellipses and sort of other such things made out of straight surfaces that are bent in one direction. But I think spatially it makes quite a big difference turning it into a sort of straight surface. And I suspect structurally these curves probably have some sort of structural potential as well.
Yeah, I mean, there's the opportunity, isn't there, to sort of generally add more stiffness through the curvature in there. I mean, triangles are good as well, so I think there's something in that. There was a kind of pragmatic kind of sense to the pursuit, I suppose, wasn't there? I mean, I guess the sort of single curve as well is the middle ground, isn't it? Which I guess got lost along the way, did it as well? You know, I think trying to do the full twist, I guess, would maybe be a bit more about a sort of side study that sort of took the technical question into a different thing later in the day. But
we can share the different iterations that the core went through to show how at one point it did have
Yeah, as Martin mentioned, I think it's important that Dimitri followed up on that kind of logic and kind of developed the project more independently.
Right.
So, those observations will be really acute later this afternoon.
I think it's like to sort of move away from the technical as well, but I think the question of the space.
The stuff, you know, when I was in high school, the stuff I was looking at was things like, do you know Shelter and the Dome books and so on, as the sort of counterculture era sort of publications and so on. And actually, I lost them all somehow, and few months ago, I bought a reprint of Shelter, and just slightly curious as to what I think of it now, sort of several decades later, and this is much more reminiscent of that sort of world of bespoke things made out of contingent situations and so on, and trying to find a resonance with the place and nature and so on. You know, that seems story, and I wonder whether the lessons for commercial housing are not so much in it as a prototype thing, but the sort of questions or attitudes of making, and maybe what parts of the project might be made. You know, are there parts? Is there a core that is made industrially, but maybe the sort of the stud component, for instance, being a much more bespoke thing that can be made locally by the inhabitants in a way that is particular to situation, available materials, personal desires, requirements, and so on. You know, is it actually suggesting a different sort of model of industrial house production?
Yeah, actually, we just kind of looking for what is available from this side, is kind of local thing. And actually, most of the timber in our building is, you know, like the firewood logs, and also most of the stud and the floor and roof system, the structure is reused by the self-seasoning shelter. We just like cut the wood again. And also, I think for all of the materials, especially for the big scales, like the logs, we could reuse it again in the future.
I understand that. It's what seems very attractive about the project are all sorts of things that would seem counter to industrial production. You know, sensitivity to what is available, contingencies of availability materials, the using materials that are very close to the place, a sensitivity to the particular site where you're building, and so on. You know, that all the things that you're valuing and enacting would seem antithetical to industrial mass production. And so I think that the question is, you know, if you want to discuss the commercial housing story, are there lessons from this about what are the parts that can be usefully mass produced, and what are the parts that might be made in a much more contingent sort of way?
Can I?
Raised his hand. Should we let him?
Yeah.
Jump in.
Yeah, I mean, it's a bit hard from back in my
muted,
room,
I think.
but I think this is this point is crucial because
That might be my problem. Wait a minute, Jacopo, we can't hear
sorry.
you. Just a sec. All right, try now.
Can you hear me now?
Yeah.
I think a part of the argument that we are trying to make with this project, it's not only the object itself, but the object as a vehicle to promote a mode of land management. So we have something that, especially initially, was intended in the core to be more industrially produced, considering like the curvature, the use of a robot. But in orders of pragmatics, we had to change and scale down a bit. That had the ambition of something more technical, but at the same time, it was meant to be combined with the Stud Plus as a way to promote and you know, have something that is like a prompt for people to manage their land locally differently and allow them to have this canvas represented by the core on which, using the simplicity of a light frame, they can intervene and change and take more ownership of the whole space and the envelope, having the this rigid frame as something more reliable and that gives a sense of stability.
I think one thing to add to this quickly is just like we've noticed that this house has kind of gained the name the prototype house, and I think that's kind of great honor, and it's some semblance very kind of like embodying the prototype house that Hook Park originated from. So Hook Park in the 70s was started because thinnings were just a massive waste from monocrop forests. And in talking to John Makepeace, the intention was not to make every commercial house the prototype house, but to influence through the ways that we regard timber and the way we approach that system. Because in these economies of scale, there's no space for that innovation. So I think this place is a good precedent.
Yeah, this is a question for you more specifically. Is the house itself seems to have moved in form, but also in situation amongst the other buildings at Hook towards the Carlos Garpa A-frames that you used as a precedent in the essay a year ago. There seems to be multiple scales. It seems to have some of the spatial and joyous qualities of that camp in the mountains. It seems to be towards that.
I think, I'm not sure it was entirely a conscious decision, but it had...
No, hang on.
Oh,
It's
sorry.
me again. Apologies.
No, no worries.
Trying to get the speaker working in the middle. 2 secs. All right, go.
Okay. So yeah, I think this is a very poignant observation because I'm not sure we did it at a conscious level, but it has this, in terms of like aesthetics, a very similar approach in trying to combine the soft and the hard, the polished and the rough, and having this balancing of different material and central properties in the whole, in the way the space is structured. Like the rail in the Scarpa cabin you were referencing, half of it is made of steel, the other's a rope. I think that captures the idea of our project in a sense well, with the rigid core and the fairly soft tent-like quality of the stud plus.
Yeah, is there I think this follows on from what Matt was saying, is there a core that could be industrially manufactured? What are the key elements of the house at the minute, or things you could add, such as the handrails that would define the spatiality, experience and sheer joy of this place? A sort of compendium of definite parts.
Yeah, I think the core wall is the more industrial friendly component of the whole design, as it was meant initially, and even if we simplified it, it still is more in that line, and it creates that that framework in which you can build inside more bespokely and with a lighter touch.
This is for everyone. Looking at the house at this stage as something still, it's a prototype, it's in development. Are there elements that you could identify that are very successful in the terms of your ambitions of that would be absolutely central to an evolution of this? I was thinking of that dual handrail, Jacopo, something that's so much a signature of the building. What are the signature elements?
I think the belly, for one. I think there's a lot to play with there and how it kind of interacts. And I think the cladding could be really interesting to change, experiment with something more rigid. Maybe.
Is that the belly, the A-frame?
No, the belly is a stud.
Oh, right.
Okay. Belly.
Yeah. Okay, there's a beer belly.
Yeah, exactly. You can't just cut it out, and yeah.
It feels like one of the really successful things is this kind of state change from completely kind of closed off to completely opened up. I think that's really successful. I'm not sure about the environmental condition, like, you know, the temperature control within it seems to kind of, you know, I wouldn't say it's a red herring, but maybe it was too much to ask, right? And I think it's important to be explicit about that, like, because there are two systems that are trying to work together, asking quite complete different kind of questions, right? Like the intimacy of the A-frame and the bedroom, you know, and trying to contain that temperature. I think that's a really clear ambition. The kind of the program of the other spaces intentionally kind of quite multiple in a way, but I think again the most successful thing is that state change, right? That you can kind of completely open it up. And I think what's really enjoyable is the components that you borrowed from kind of the boat building, like, you know, all the little detail. It feels like there's real pleasure in the detailing of the ropes and the pulleys, and, you know, so those moments that you really get hands-on with the building seems to really, you know, just kind of celebrate this ability of this construct to change to such an extent. I think that works really well within the construct. So those, I think, are really moments to celebrate.
I also think that within that I don't know, maybe marine technology is a bit much to call it that, but boat building technology to marry that to more conventional architecture, building technology. I think that's really nice, but maybe what it does is that it actually talks about an architecture or a building where much more is required of the inhabitant. Like, for instance, living in a normal building or kind of normal building, they try to resist us doing work to the buildings themselves. Maybe you have to move the leaves once a year or clean out the various parts that get filled with leaves. But this building somehow almost every day allows you or asks you to go outside and adjust the windows and stuff like that. So maybe in that there's actually quite a radical suggestion for what the interaction between inhabitants and building are, that more is required. And some people would say, well, that's definitely not for me. But those are, you know, a large segment of people who choose to live in houseboats and in boats and so on. So I think maybe further on, there is maybe a completely different way to see how you engage with a space. And this is like maybe this kind of hands-on thing that Emmanuel talked about. But I think that's like these maybe not discoveries within the work that hasn't been fully put into words that I think are sort of simmering under the surface that are really, really nice to slowly unveil.
Just wondering if there are any questions online.
Are there any questions from the online?
Yeah, can you hear me okay?
Yeah.
Great stuff. Well, firstly, congratulations, guys, on finishing the project. It's really nice to see it in its completed state. I've kind of seen it in bits and pieces along the way. I think one thing I'd like you to sort of expand on a little bit is the sort of selection of the position and orientation of the site a little bit more. For me, at least, it feels, particularly that shot that you were showing a little earlier, of the main kind of primary window that looks back towards the workshop and road. And as a multifunctional space that's particularly being used sort of like a studio and a living space, where you're going to be kind of getting changed, getting undressed, lots of quite private activities, that being the kind of the primary window facing that orientation sort of feels like a bit of a compromise in that you were trying to kind of make this thing work. I remember you mentioned potentially using it as like a DJ booth, something like that. I mean, obviously for that use, it would be perfect. But maybe as a private living space, sort of feels like maybe you'd have that curtain drawn more often than you'd like it to. I wonder if you could just talk a little bit more about that.
Yeah, I mean, it's not really going to be used as a private living space as much as it will be used for students on a daily basis, however they want. And so I guess it's just a place for temporary kind of respite in which you may have the curtains drawn. But I think more important, we wanted this building to give back more than kind of take a sense of privacy.
Sure.
I think it's me again. there's two conversations, isn't there? There's the critique and evaluation of this building in itself, and there's obviously another conversation which has been being had, which is where are these pieces of this building? How do you envisage them playing out or being kind of disseminated in the world, right? And it would be really nice, because it seems to me this building comes very clearly with a piece of forest, right, attached in relationship to it. And I would really love to see a drawing which shows a kind of potential, like a speculative potential of a wider network of forests, maybe within the local Dorset area, right? That actually, so we see an idea of say what you think this a house at full scale would be, but also with its relational consequences. So that's the forest and its supply, and I think the conversation about partially industrially mass produced and partially to do with networks of local craft. I mean, particularly the sail making. That's also a knock-on consequence, right? Because that involves a community of makers. There's something quite beautifully invested about a group. Perhaps there's a network of existing community hubs or local village halls and forests, and see that kind of web is and then the house in the middle, right? Now, it would be really nice to kind of, the building, it seems to me, is a bit like, you know, you get these taster menus at a restaurant, right? So it's like a little bit of this and a little bit of that and a little bit of this, but it's really kind of a suggestion. And those taster menus have a specific purpose, that's to allow you to kind of get a sample, get a sense of the whole, right? And it would be really nice if we see it like that, for you to try and draw or conceptualize the bigger whole that you imagine and kind of speculate. And it's hard to do that while you're in the middle of bashing pieces of wood together, right? But now I've got to this point, I think that's actually to kind of pull back a little bit and say, right, we've built it. Now let's kind of open out a little bit, and even if it's one drawing that kind of speculates beyond the taster menu.
Did you guys get to have any engagement locally? And hopefully COVID derailed things. Always time I saw like Tim Crabtree's name in the audience there, like he's actively trying to do exactly what Kate's describing. Exactly. You know, there are communities wanting to find ways to to self-build or community build using their local resources, you know, and I think there's a sort of top-down kind of global kind of question of the kind of commerciality of it, but there's also just there is a hunger, you know, people want to live differently than buying the kind of the mass sort of the UK commercial house building houses are grim, you know, and there is a desire for that. I don't know, but it's been interesting whether any of that conversation had happened, or whether there's any sense of that potential that Kate's talking about.
We have actually been talking to him, and he's told us about his work with the Roof, which is trying to do just that. And so he came here, I think, to speak to the Wood Lab, and we ended up presenting our project because it was so alike. So we did go to a town hall meeting to present our project, which is something that was really great for us, and we decided to leave it out of the presentation. But I think that gives a very realistic kind of grounding of this project, in which, like, we're architects, we want to be grounded in that kind of community as well as the forest, which is the thing which produces our building. And if we had a client, then maybe that would be as much involved. And I kind of Nook is our client, and so that's the community that we've built in. But
we've got a question online from Farid.
Yeah. Hey guys. I can hear you. It's good to see you, everyone. As a previous student of Hook Park, it's very, very lovely to see this project and see you guys finally finish your project. I had a question regarding how is it that what is the greatest takeaway that maybe you have from this project after you finish it? I mean, the one thing that is kind of very difficult to present to other people is what's it like to be in Hook Park itself, right? It's having been there for like, you know, a year and a half now or something like that. It's kind of hard to describe the place itself. I've narrowed it down personally from my experience to like, you cannot have any privacy in Hook Park whatsoever. And it's kind of nice to see like this project kind of emphasize that a little bit. Like, you know, it's like a house, but at the same time, it's like I imagine myself sleeping here and like, but then behind the curtains, anybody could hear what's happening inside, and I could hear everything that's happening outside. You know, it was just kind of nice. I like that. It's kind of, it's new, it's interesting. It's not you know, it's not the normal thing, which is very characteristic of Hook Park. It's not normal, you know, and I like that. And so, just a question to fill my own curiosity is, having worked together, having built this wonderful project together, and having, you know, I'm sure exhausted a lot of efforts on it, what would be something that you would really take away from this, and how do you think this build project is going to influence your lives as architects, or I guess whatever else moving forward with your lives, I guess? I'm just trying to be very reflective when I look back at my own project and how it helped me now as someone who's working as an architect. And I want to see if you guys have any considerations. Maybe it takes more time to synthesize, but if you've thought about that. Sorry, I spoke too much.
Yeah, I mean, this is a very, very big question. And at least for myself personally, I think the biggest difference before and after should be, I will never design something I think it should be easy, but actually it was super difficult to realize it. Like when I designed the curved wall, actually the curvature is not that crazy. Everybody just feel actually it's fine. We could use everything. We could got lots of support to finish it. But when we really working on it, we feel like almost everything is impossible. So yeah, it's just like yeah, calm down a bit and rethink everything like maybe more detailing. I think is the biggest difference. I mean, changing for myself.
Curve is easy in Rhino.
Easy, right?
You have a great big list of ambitions in the project. Probably way too many, you know, in a way. But one of them is about efficiency of the use of materials. And if we look at examples that strive for that, and especially thinking back to the sort of counterculture, similar desires and counterculture buildings, things like the geodesic domes, the Fuller domes, conceptually have a very efficient use of material, but in fact require a lot of cutting of material to get that lightness, have sort of shapes of things that use material in a rather inefficient way, and so on, and then really very hard to occupy in terms of, you know, standard things, furniture and so on and so forth. And then you get maybe things like, say, the Jean Prouvé schools that use material incredibly efficiently, but can really only be extended within the logic, you know, the extruded logic of the structural diagram. And certainly the dome's very hard to adapt. And you're maybe taking Kate's prompt, your sort of architectural tapas here of different pieces. For that to work, it probably requires quite a lot of redundancy. You know, that efficiency is not your friend in many ways. that if you want to take a piece out and change it, or if your piece wants to meet your friend's piece, they might not want to lean on each other or rely on each other or be dependent and so on. I wonder, one is in that discussion of a sort of efficiency and the sort of broader desires of the different parts. Have you any thoughts about that play off?
Yeah, I mean, one thing, thinking about efficiency of material, just or even in terms of fabricating and constructing, like, so we kind of designed this model, having made prototypes, but never made the two buildings together. Each were prototypes on their own. And so we designed this digital model of how we put it together. Everything was as efficiently using material as possible. And then when it came time to construct, we realized that actually fitting these two in, it was almost necessary to have this like redundant structure to just be there to fit them, because it was just like two different languages that were built separately. So I think in hindsight, like, redundancy isn't necessarily a bad thing, and it is more efficient than not.
And maybe in terms of the longer use of the project might allow many other things to take place.
Totally, that was the lesson learned.
When I was living in Canada, there was a site that was being redeveloped, and it had a roller skating rink on it and a bunch of houses, and a lot of these early 20th century houses in the city came from Sears catalogues, where the material was pre-cut but arrived in a sort of flat pack, if you like, by train. And a friend who was working on the project was very keen to recycle these houses as completely as possible, and thought that this would be easy because they were these generic detached, with fire breaks between each of them and so on, and thought they'd be very easy to recycle as a result. And in fact, they had been adapted so much that they've become incredibly particular to their suburban situations. And it was actually, it needed a lot of work on them to allow issues of things like overlooking and so on to be resolved in their sort of new location. But they had this capacity in their redundancy to both be adapted and then subsequently reused and adapted.
I think that's probably a really nice comment for us to actually go have a look and see for ourselves and engage with the building. I just wanted to.
Wondering if anyone on the floor, in the back row, or
Cheap seats.
Have any comments before we go?
The online people able to follow it or not?
No, I think I might try with my phone, but I think let's when you get internet connection out there.
Yeah, just with my phone.
Yeah, you could give it a go.
Is there anyone else online now?
Anyone else online want to make have any comments?
It's easy.
I just wanted to say briefly the itinerary for the rest of the day. We're going to go out and look at the building now, so hopefully the internet connection stays up. But our next agenda or meeting point really is we have the real pleasure of having Nat as our keynote lecture at 1 o'clock. So please join us for that, and then the jury. We pick back up the jury at 2:30. So I think that's just important to note for everyone online that wants to stay with us.
We'll give the remote connection a try, but if we drop out, we'll be back at 1 for Nat's keynote.
Great, let's go have a look. Thanks, everyone.
Thank you.
Thank you.
Do you want to take the with you? And the mic?
Yeah.
There is that.